for gaining electrons. For gaining electrons were all going in the forward direction. So they were going to gain electrons. And so it was minus point. 83 volts, the higher one wants to gain electrons. So we searched for the higher one and we found that route. Now, on the other side, so let's focus on the other side now. On the other side, it's either Cl minus one that's going to lose electrons, or it's again going to be water that's going to be losing electrons. So I'm going to go, and remember, you don't have a choice. So you don't write a reversible reaction. What you're going to do is you're going to find equations where either Cl minus one or H2 are going to lose electrons. So open the data booklet, and remember the equation is going to be in the backward direction. Over here, the equation was in the forward direction. So we were dealing with the forward reaction because in the conventional way, the equation is written, the forward is the one that gains electrons. Over here, since we are looking for the lower E naught, the one that loses electrons, it should be in the. So this equation must be in the backward direction. So you've got two options, Cl minus one or H2. So open the data booklet, look for the equations where Cl minus one is on the right-hand side now, because we want it to lose electrons. So if you look over here, there is Cl minus one over here, and we wanted to lose electrons, two of them. So I'm basically thinking of the equation in the backward direction. I've got a Cl minus one over here as well, but I'm not going to use that because that Cl minus one is with OH ions. We don't have OH ions in our experiment. So we're not going to use that. So it's got Cl minus one losing electrons to form Cl2 plus 2 electrons. Let's write that down. So it's two, just one second, 2 Cl minus one. And they're losing electrons, so arrow in the backward direction, and it forms Cl2 plus 2 electrons. So I've written this equation over here, but in the backward direction, and there is no reversible sign. And this value is 1.36 volts. So this one has a value of 1.36 volts. What about the other one, water losing electrons? So let's go and have a look and find equations where water is losing electrons, and water has to be on the right hand side. We don't want it to gain electrons, we want it to lose electrons. So I've got two equations. I've got one over here and one over here. In both cases, it's water that is losing electrons. So in both cases, water is losing electrons. So let me copy the equations. So it's two water molecules. So the first one is two water molecules losing electrons to form H2O2 plus 2H plus 1. Plus what else? Plus 2 electrons are lost. And the value is 1.77 volts. And then you have two water molecules, and in the second equation, they're also losing electrons to form O2 plus 4H plus 1 plus 4 electrons. And the value for this is 1.23 volts. So I've copied two reactions. Remember, in the backward direction, I want them to lose electrons. So here are my two reactions. So who loses electrons? The one, I mean, you've got two options. They're trying to lose electrons. So who loses electrons is the one that has the lowest potential. The lowest potential is this one. So this is the correct equation. So out of both of them, it's water that really likes to lose electrons. So in this electrolysis, this is the reaction that you're going to get at anode, and this is the reaction that you're going to get at cathode. So I'll just briefly give you an overview again. You had your reactants, Na plus 1, Cl minus 1. You had no H plus 1, no OH ions. Instead, you had water on both sides. Electrons are coming in. We're trying to figure out who gains electrons. So I look for the equation in the forward direction. I want Na plus 1 or H2O to gain electrons. So I'm going to copy those electrodes. I'm not going to add a reversible sign because I know they've got only one option, and that is to gain the electrons that are coming from the battery. So, and between the two, who really wants to gain electrons? The one that has the higher E naught. Over here, I'm looking for equations where they lose electrons, either of the two, because the battery is pulling electrons away from them. So I find equations in the backward direction, Cl minus 1 and H2, or two for H2 or 1 for Cl minus 1. And who likes to lose electrons is the one that has a lower E naught. So is this all clear? This one? E clear? Sam, is this clear? Zahib, Zoha? Hafsa, is this?
Yes, sir.
So this is what you're going to do. I mean, and you'll just mark these equations on the data booklet and you'll try and solve this. So we're going to do a couple of more examples for this. Let me just copy the same thing, and we'll do copper sulfate now, because copper sulfate is something that used to frequently come in your O levels. So I'll just so we'll try to do copper sulfate now. So copper sulfate aqueous. So what do you have when you have copper sulfate aqueous? It's so remember aqueous. So we've got copper 2+ ions, and we've got on the other side, we've got SO4 minus 2 ions. And what else do we have? We have water, and we've got on the other side, we also have water, which is everywhere. So over here, we're going to decide who loses electrons. Over here, we're going to decide who ends up gaining those electrons. So the choice is between copper +2 and H2O. So remember, find equations involving copper +2 and H2O. So for H2O, we already did find equations. So I'm just going to copy that. It was this one, the one with 0.83 volts. Okay, so we had already found one of the equations. We'll just, I'll just copy that. And I'm going to find equations for copper +2. So I'll just open the data booklet. And remember, I want copper +2 to gain electrons. So where is copper? And remember, it should be in the forward direction. So I've got two reactions for copper +2 where they are gaining electrons. And so I'll just copy both of them. So it's so this one is Cu +2 electrons. And they gain electrons to form copper, which is 0.34 volts. That's the first one. And the second one is copper +2 trying to gain just 1 electron and forming copper +1. And this one is 0.15 volts. So I've copied both of them, and I'll just, so here's my board. So the decision has to be made who gains electrons, the one that has the highest potential. And in this case, it's the middle one, that's 0.34 volts. That's the one that has the, that has the high E naught. So that is the one that's going to gain electrons. And this is exactly what you had studied in O levels as well, that copper ions are the one that are going to get reduced. And they're going to gain electrons to form copper. Now, on the other side, you're looking for equations where water is losing electrons or SO4 minus 2 is losing electrons. So for water, we have the same equation. So I'll just copy the same equations for water losing electrons. So these are the two equations for water. And at the moment, I haven't selected this one, so I'll just remove that. And who else is there? There's SO4 minus 2. That can also lose electrons. So go and find an equation in the reverse direction where SO4 minus 2 loses electrons. So here's an SO4 minus 2. Equation where it loses electrons. So I'll just copy that. and it's losing 2 electrons, and this is 2.01 moles. So here's the equation. So we're going to decide who loses electrons. The one that has the lowest E naught, that's the one that's going to, and that is coming out to be 1.23. That's the one that has the lowest E naught, and that loses electrons. So we've figured out our cathode and anode reactions in this case as well. Okay, is this clear?
Yes, sir.
Now, so in all cases, you're going to do the same thing. So, and remember, you're not going to waste time copying these equations. You'll just mark those equations on the data booklet. Now, about yesterday's class, we did discuss if you change the potential, let's bring this down a bit. In yesterday's class, we did discuss that if you change the concentration, the potential varies or changes. Now, in the case of copper sulfate, changing potentials is not going to have a drastic change, but in the case of NaCl, if you remember O-levels, in O-levels you had studied that concentrated NaCl, if NaCl is concentrated, like if you remember this, so if NaCl is aqueous is concentrated, then chlorine is the one that is always discharged. So this is something that you had studied in your O-levels. So how do you link this with this one? Because clearly chlorine is not the lowest potential, because the lower potential is the one that's going to lose electrons. Now the thing is that if Cl minus 1 is concentrated, what would happen to the equilibrium for Cl minus 1? Like over here, if Cl minus 1 is concentrated, the equilibrium is going to shift in the backward direction. If you have a higher concentration of Cl ions, this equilibrium would shift in the backward direction. It's going to produce a lot of electrons and the potential would decrease. So let's say if Cl minus 1 is very concentrated and the potential decreases to, let's say, I'm going to use some value, let's call it instead of 1.36 volts, let's say it decreases to 1.15 volts. So what happens is that if it decreases to 1.15 volts, so the first thing is I'm going to just write quickly what is happening here. Okay, if NaCl is concentrated, then the equilibrium that we're talking about, which we said was 1.36 volts, the equilibrium shifts to the left and the potential decreases and becomes lower. Now, if its potential decreases, now the lowest potential out of the three is the Cl minus 1 potential. So now the scenario is that instead of water getting discharged, it's going to be Cl minus 1 that's going to be discharged, because Cl minus 1 and water had very similar potentials, 1.36 and 1.23. So by just slightly altering the concentration of Cl minus 1 ions, you were able to reduce the potential value. And if the potential value decreases and it becomes lesser than 1.23 volts, then it's going to be Cl minus 1 that would be having the lowest E naught. And that is the one that would be getting discharged in preference to water. So did you get this point? समझ आया Zaheb, Zoha, Maya, Alicia, did you get this?
Understood, sir.
So I'm just going to write that if E naught, sorry, the new potential. So they ask a lot about this. So if new potential becomes lesser than 1.23 volts, which is basically your water losing electrons. So that was the oxidation of water. Then Cl minus 1 will have the lowest E naught. And will be preferentially discharged. So is this clear? This thing, and remember this changing potential can apply to many things, but usually just it only comes into play when the difference in potentials is very, very less. So for example, this 1.77 is out of the question because you change the concentration, the potential is not going to increase that drastically. So this one would probably, I mean, its value would never switch or become the lowest. But these two, they're very close together. So their potentials can kind of become, the lower one could become the higher one. And similarly over here, the potential differences are very, very, I mean, the difference between this and this is there's a large difference. So even if you change the concentration, the position, the one that has the lower E or higher E naught, it's not going to change because there's a lot of gap between their potentials. So usually changing concentration only comes into play when you have Cl minus 1 and the difference is very less. So let's continue in the next class. We'll do more questions and then we'll hopefully do past paper questions for this topic. Okay. So let's continue tomorrow then. So okay, everyone.
Thank you, sir. Allah
Okay.
Hafiz.
Allah Hafiz.